Okay, for today's class, we're going to be talking about the idea of matter, the three states that they are in, some ways that they can change, and I'm going to be clearing up some misconceptions about matter along the way. So, the question can come to mind of what is matter? Just imagine anything that can take up space and has mass to it. Because, like, say, for example, this eraser is an object that technically is matter. It is a solid object, it has matter, it takes up space. That is a good example of what matter can be. Imagine like a phone that could also take up space. It is a solid object, and it also, again, it takes up space in your pocket or in your hand or on your desk. Any one of those three is fine. Okay, and you notice how I said solid at the beginning? Okay, so what is a solid exactly? Well, matter comes in three states. At least for this level that we need to know right now. Okay, the three states of matter are going to be a solid, a liquid, and a gas. So the question comes to mind of what are these three states of matter? A solid is just anything, like any form of matter that is going to change, like always going to stay the same shape, and it will generally always have the same amount of volume or anything that comes to mind of just like weight or anything that fills up an object. The reason why these are important is because the same shape and same volume basically is what the defining factor of a solid is. So just imagine something like an ice cube. Just pretend that this is an ice cube right here. It is a frozen solid bit of water formed into a solid piece of ice. Okay, liquid. Liquid is a weird case to where the volume for liquids can often stay the same, but it will often have a different shape depending on like what is holding the liquid in. So if you saw like a bottle of cleaning spray, that would be a good example of cleaning spray would be a good example of like a different shaped liquid. Imagine water in your water bottle, or in this case, this water jug right here. It is technically the same amount of volume, but it's coming into a different shape. Shape can mean about anything. It could be water containers, it could be bottles of water, it could be any plastic cartons, it could be anything of that like. Gas is often a bit trickier to describe, but just imagine, okay, it's both different volume and different shape. The reason why this is important is because gas in particular is more or less just like, imagine the air around us. Imagine filling up a balloon, imagine filling up an air mattress, anything of that sort. Imagine steam coming out of water. All these can come into mind as their own. I forgot to draw a water example for liquid, so we're going to set that up right now. So for gas, just imagine this is just a balloon flying up into the air. Like that is, the air inside of this balloon is an example of a gas. So why are these three states of matter important? Is because everything around us exists in one of these three states of matter. So a solid object on our phone, the water we drink, the air we breathe, all that is because of the three states of matter in mind. So the thing you're probably not wondering is, okay, can any of these change? Or do these all stay the same? A major thing that I notice with people learning early on is that students will mistake the states of matter as never ending or never changing, when that could be further from what it actually is. So matter can change, but it has to go through process or any form of change where it'll have to change from one state to another. Let me just write this down. Is there any question that anyone wants to ask? If not, y'all can remain silent while I finish writing this. Okay, so matter can change it, but the question is how do we reach that? So let's say I wanted to go from a solid to a liquid. How would I go about approaching this? The first term that comes into mind is, okay, I can melt the solid into a liquid, and that is the term that we come up with for melting. So just imagine an ice cube being melted into water. Like that is a great example from a solid to a liquid. But the question is like, can any material melt into it? And while some can, others cannot. It's going to be harder to melt a wooden table compared to just like an ice cube or a stick of butter into like their liquid forms. So these two examples in particular showcases that not every solid is going to be the same. Similar with like the same set of liquids and gas as well. Not every solid, liquid, or gas are going to be the exact same. Solid especially needs to get this point across because even something as small as like a cotton ball, to where it can technically change depending on like what pressure you give it to it, or like what transformation you make it. The cotton ball will often still be a solid because it is still going to be the same shape and volume. No matter what, it is always going to be compacted together, and it'll always be a solid. I wanted to clear this part out of the way right now because butter is an example of a softer solid. The wooden table, as I previously mentioned earlier, is like a harder solid, and ice is somewhere that is a great example of how a solid can melt, because through the melting process, it often relies on heat to melt it. So heat is more or less what can cause the solid to turn into a liquid, and the process of melting to happen at all. Because even like small amount of heat can melt ice into water. So if I put an ice cube in my hand right now, which I cannot because I don't have any ice with me, it will melt into water. You can possibly try it yourself and write down the results back over to me later after this class. But the main point of melting is that a solid changes into a liquid through heat. And some examples, I wanted to clear up the misconception of softer solids versus harder solids, because every single solid can be different, every single liquid can be different, every single state of gas can be different as well. Okay, I'm going to have all this provided on Google Classroom or something else later down the road. So if there's any questions, you can talk to me about it, or you can consult back with this video lecture. Okay, so we know what melting is. We already know what that is. So question is now, can a liquid turn into a solid? And the answer is yes. And that is through the process known as freezing. Freezing, even though it takes heat to melt an object, it'll often take a lot of like colder temperatures to freeze liquids into solids. But while I'm also here, I'm going to point out just freezing can just more or less just like freeze any form of solid. So imagine like you left a t-shirt outside while it's like snowing and icy out. The shirt is frozen solid. The material's just firmed up and just became harder. So any solid can be frozen as well. I'm going to write this over right here. But for liquids to solids, just imagine freezing water, freezing juice, freezing milk, freezing melted butter. All of these are good examples of a liquid transforming it into a solid. This is more or less just a basic idea of freezing, and just imagine, okay, so the best way I can possibly describe it for you guys to remember, imagine melting involving heat and freezing involving cooling. they're the opposites of one another, and they are states of matter changes that can easily go back and forth. There is no other questions left. Okay, so we've only been talking about the two states of matter. So the question is what is the third state of matter's involvement with this? And the immediate example that we're going to talk about today is just going to be the concept of evaporation. Evaporation, more or less, you ever notice a puddle? I'm just going to draw this as just a larger puddle. You come back a couple days later, it's just like a smaller puddle. You notice that part of it is drier now, so the question is, where does the water go? And the answer is evaporation. Evaporation is the process of turning a liquid into a gas. In this case, it's just going to be the vapor in the air. Boiling is another good example of a liquid to a gas, because it is going to be just boiling water, and then this is now going to be replaced with steam. Steam is also a case of a gas because it is also coming from a liquid and is also another example of evaporation. These are the three states in mind that we all have questions about, and these are the three that we're going to be seeing the most in day-to-day life in the world. Evaporation is the part where gas can often be connected to liquids or indirectly solids. Because I can easily write about how do I turn an ice cube into just steam, and the answer is just going to be melting the ice into water through melting, and then I can evaporate that water to turn it into steam. Like, that is a great example of how the states of matter can change, because this example shows that like ice can melt in the water, and I could boil it to evaporate the water out and turn it into steam, raise the temperature up to where steam will start to come out, and be a good example of a solid turning into a liquid, which turns into a gas. You're going to be seeing all these states of matter everyday life. Not all of it you're going to see very often, but it is an important part that we need to learn. Okay, so I'm going to ask you a surprise question. If I wanted to turn water into ice, how would I do that? What process would I go? You guys can stay silent with this. You guys can write down your answer and put it to the board. Since there's no one here, I'll have to write down the answer myself. But I could give anyone that is watching the lesson time to think about it and answer the question on their own. The answer, if I wanted to turn water into ice for this example, would just be freezing. Because water is a liquid and ice is a solid. Liquid into solid. And freezing is just changing a liquid into a solid. That is a great example of this. And this is more or less the three main states of matter and how they can change. But before I end everything off for today, though, I do want to talk about some smaller things that I see often. So I talked earlier about liquid and how it can have a different shape. This part is important because the volume will often be the same. So the closest example I can grab out of this is, imagine I grabbed 2 bottles of any random soft drink. I'm just going to draw these and just write down Coke for both of these. I know this is a terrible drawing, but you're going to have to work with me on this one. The volumes are going to be roughly the same, so let's say this has about like 15 inches of Coke, and this one is also 15 inches. So, and then I'm going to pour one of these things of Coke into a very wide tray. This is still 15 inches of Coke. I know this is a terrible example, but this is just like a fast example I could pull up as a reference. So liquid, more or less, different shape, but the volume is the exact same. I forgot to talk about this part, while it's covering liquid, but it is important for me to go over again because this is a very easy misconception to have, and you're often going to see cases where people will just pour the same liquid into a different container and people are confused at why one is apparently taller than the other visually, but it doesn't look to be the exact same, even though they are. So liquid is always going to be a good example of the same amount of volume into a different shape. So some of the main points for today's lesson is more or less the idea of there's always going to be three states of matter. They exist in our everyday life. There are ways to change these states of matter into one another depending on what the exact matter is. Because like the ice in the water situation is always going to be a common example of melting and changing a solid into a liquid. But this is pretty much all that I have to talk about today. Matter is always going to be anything that takes up space and has weight to it. The three states of matter are going to be important in our everyday lives. Understanding this helps our understanding of science and material come a lot easier later down the road too. There are a lot of things that are hard to learn about this, but you can watch this video later down the road to learn more about this, or you can talk to me after class because I have any questions. But I think that this will be it. This will be the end of class for right now, and to anyone that is watching this on Google Classroom or YouTube or whatever, just thanks for watching this lecture. If there's any questions, do email me, talk to me after class, anything in that lot. But this is going to be the end of today's class, and I hope everyone learned something today.